Welcome, everyone. Thank you for joining us today for another NetHope Solutions Center webinar. My name is Madeline No. I'm from NetHope. Today, we want to welcome you to our session, Demos of AI and ML Tools and Services. Today, we're welcoming representatives from Amazon Web Services, Google, Microsoft, and Salesforce.org. Before we get started, I just wanted to go over a few of our housekeeping guidelines for today's session. We'd like to keep this interactive, and we'd like you to please post your comments and questions in the chat window for a Q&A and discussion session toward the end of our hour. Later, after the session is over, we'll follow up with an email with a link to the recording and any collateral from today's session. And we would love it if you would follow up and provide us some feedback by responding to our webinar satisfaction poll that will pop up in the session. And with that, I will hand it over to my colleague, Layla Toplik, to introduce our speakers and provide a little more information about today's session.
Great, thank you so much, Madeline. If we click to the next slide, I will just briefly provide context for this webinar series and then introduce the speakers. So again, good morning and good afternoon. Welcome to the Emerging Technologies webinar series. This webinar series is part of the capacity building work that we've been doing at NetHope to grow NGOs, so nonprofits, internal expertise and capacity to evaluate, to develop, to procure and use emerging technologies like AI. And the reason why we do this is that these capabilities help organizations make informed decisions, do their work better, as well as also be able to anticipate some of the issues that might arise from the usage of the new technologies. So if we click to the next slide, the purpose of this webinar is really focused on one of the needs in the international development sector. And that is to get started without having specialized expertise in AI and machine learning or having access to technology experts, which oftentimes are actually outside of the international development sector. And the good news is that there are actually a number of off-the-shelf AI and ML tools and services from companies like AWS or Amazon, Google, Microsoft, and Salesforce that nonprofits can start exploring and experimenting with. So the purpose of this session is to provide practical demos of several of the available tools and services. And this by no means is an endorsement of any particular tool or company. In fact, we just believe that capacity building for the sector starts with understanding what already exists, whether it's tools and services, some of them we'll see today, or some of the existing solutions and programs. Just last month, if you didn't get a chance to join one of the webinars, where we featured two solutions that were developed in-house, and one of them was developed through cross-sector collaboration. And today we shift focus to off-the-shelf tools and services. So as a side note, we will not be covering the fundamentals of AI and machine learning today, so the capabilities and benefits and use cases, since we've done that in a number of workshops and webinars. We're actually sharing one of the links, and that's to the AI and ML primer webinar, which hopefully you'll have the opportunity to review and then also share with your colleagues. In addition, the participants in this webinar, as well as many others, have contributed to a repository of AI and ML tools, services, and training. So really highly encourage you to take a look at that spreadsheet, and do let me know, send me an email. I believe Seth will be including my email in a chat window if there's anything else that you'd like to add to this repository of tools, services, and trainings. So if you click to the next slide, Madeline, thank you. What to expect in the next, we have about 55 minutes. We'll see 4 demos today. Each demo will be about 10 to 12 minutes long, so quite short, actually. And demos will feature 3 out of 5 AI capabilities that were covered in the AI Primer webinar on August 27th. You have the link to that webinar in the chat window. And those 3 capabilities are advanced analytics, natural language processing, and we'll also have 2 demos of computer vision solutions. And because we have a lot to cover, we'll have a very brief Q&A after the demos. I do encourage you to post your questions in the chat window. We always love hearing from you, both questions and comments, and then also encourage you to follow up with the presenters directly after the webinar, and we'll include their emails on the next slide. So if we click to the next slide, I would love to introduce our technical experts. I couldn't be more excited to welcome technical experts from 4 partner organizations, from Google, AWS, Salesforce, and Microsoft. And just a brief introduction of each of the presenters. Rui Costa is a cloud solutions engineer at Google. Rui developed the speech analysis framework, a tool that enables users to easily ingest audio files, transcribe and analyze speech data, and also visualize ML-powered insights. Rui also serves as the AI coach for the Crisis Text Line and has been advising the Google AI Impact Challenge grantee on their machine learning work. Thank you for joining us, Rui. Grace Kitzmiller is a principal product manager for Amazon Web Services disaster response at AWS. Grace focuses on how the cloud can be used across the disaster lifecycle in connected and also disconnected environments by nonprofits and agencies that are active in response. Thank you for joining us, Grace. Alex Kruglyak is a principal solution engineer at Salesforceorg. Alex works with the nonprofits to support and drive the adoption of technologies like AI that amplify their work and missions. Thank you for being with us, Alex. And then finally, Michael Tjalve is a principal program manager at Microsoft. He's working on Microsoft's conversational AI. He's also actively engaged in initiatives to develop and promote AI for social good. And Michael is a fellow at the Royal Society of the Arts and assistant professor at the University of Washington. So as you can see, we have a fantastic lineup of technology experts, and we'll go through the demos next. So each will have about 10 to 12 minutes. And do post your questions in the chat window, and also contact our presenters directly if you want to learn more about the demos or explore some of the other tools and services. So the first up is Rui Costa, who will provide a demo of AutoML tables with a brief introduction first. Rui, over to you.
Great, thank you. Let me go ahead and share my screen. Give me a second. Awesome. Okay, great. Do you see that? Perfect.
Yes.
Okay. Oh, awesome. Thank you. So thank you, everyone. Again, my name is Rui Costa. I'm a cloud solution engineer based out of New York City. I'm going to be demonstrating Google AutoML tables today. I'll take you through a little bit of context, and then we'll jump right into the demo. So a little bit about Google's AI for Social Good program, so I can set some context. There's 2 pillars within the program, or within Google's AI for Social Good program. There's the research engineering pillar, which focuses on developing models, as you can see in the animation around flood forecasting as an example. Then there's the other pillar, which is building the ecosystem, which I'm more passionate about, is because I'm actually part of the program, and it's bringing organizations together like yourself to help build AI for social good. From that program, there's a program that was launched this year. It was an open call to nonprofits globally, and it's called the Google AI Impact Challenge. We had 2,600 proposals were submitted from about 119 countries. 20 grantees were selected. From the grantees that were selected, they have received and are receiving AI mentorship, Google Cloud credits. There's a pool of money, $25 million, that's also been divided up amongst the grantees that were basically awarded to be granted into the Google AI Impact Challenge program. And there's an accelerator program. An accelerator program, I look at it as kind of like a startup incubator, where, again, Google provides engineering resources to help accelerate the project that was submitted to the Google AI Impact Challenge. So super exciting and I'm super excited to be part of it, because I'm an AI coach helping the Crisis Text Line within this program. So to get into AutoML tables, I want to just kind of set some context. Just kind of what is AutoML? How does that fit within Google Cloud's umbrella of services? So AutoML tables is for structured data. it sits within our AutoML portfolio. And within AutoML, our portfolio, it does not only include tables, it does include things like vision, video, and I'll touch a little bit on that for unstructured data. So look at AutoML as the umbrella product, and the service that are under there is one of them, which we'll be covering today, is tables. And tables is specifically for structured, supervised machine learning. So I put this slide, it's a very busy slide. I'm not going to go through all the bullets here, but I put this because this is a traditional model build. And to, again, set some little additional context, people might be like, okay, what is AutoML and why is this making this a little bit more simplified? So I look at the kind of left-hand and right-hand side. And what is the left-hand side? The left-hand side is, you leverage an API, for example, like a vision API. You send an image and you get some classification back. This image is a car. On the right-hand side, you have something where you're actually building your own TensorFlow model. So you need the expertise of like Jupyter Notebooks, Python expertise, etc. And in the middle is what we developed and what we call AutoML. And AutoML basically bridges the gap between the left and the right. So leverage the foundational models that have already been developed by Google, take your data, train a new model for your use case with your data with no expertise required in, say, Python or Jupyter Notebooks. Do it all within a graphical interface. So this slide is busy because this is that right-hand side. This is building your own TensorFlow model. And this is not a process that you run through the journey once. You can probably rinse and repeat this multiple times. So you're going through this maybe 5 times, 10 times, et cetera, and further until you get to that model evaluation phase and you determine that this is the right criteria that you've determined when you first initiated this project. If it is not, I'm going to start this process again. And these processes are not, hour-long processes. These can take, days, weeks, and months to go through this journey. So for example, like feature engineering is what features are going to be relevant to my model. Do I remove a feature? Do I need to add additional features? That process alone takes time to go through that journey. Hyperparameter tuning. What is hyperparameter tuning? That's another thing that becomes very challenging. How do I even do hyperparameter tuning? What Google AutoML, specifically tables, and our other product services as well under the AutoML umbrella, abstract that from you. So we take basically that responsibility and we provide you as a managed service. Just give us your data. We'll do all the middle, and then we'll basically present you the evaluation so you could determine if this is a model that you want to use in production. So again, I kind of touched on this, but AutoML tables, AutoML, the umbrella of services, is not just tables, which is for structured data. We also have products for unstructured data, things like vision, video, natural language, translate, and now you can start thinking about some of the use cases there. So I can take vision data, my own images, and start basically doing supervised training on it and building a custom model for me without having to even open up one time a Jupyter Notebook. All I'm doing this is through a graphical interface, a spreadsheet that I'm uploading with labeled data, and now Google's going to build me a new AI model that I can leverage. And for our focus today, for the demo, we're going to be focusing on structured data, which is AutoML tables. On this, this is that right-hand, left-hand side a little bit, but what I want you to kind of ignore the middle for now. The important thing when you start this journey with AutoML tables is what is your data? Where is your data? How do you get your data to Google? And we have a couple of different mechanisms. And then here's my model built out. And all that middle piece, all those boxes in the middle is what we're doing for you as a managed service. So you're doing this through a graphical interface that I'll demonstrate in a few for you. We do give you some ability to change some settings. So I can choose a model. I can choose a feature to include or not include. So we're giving you the ability to do this through a graphical interface, but you're not having to do it programmatically. So we abstract in some form or other the AutoML, the middle box, and you just have to worry about getting your data and then making sure that this is the model that you want to use, and then how are you going to leverage that model in a productionized workflow. So for our demo, I went to Kaggle. I chose a data set from donorschoose.org. It's an application screening. So teachers around the United States submit applications for funding for student projects. They get an enormous amount of applications. All these applications are selected to be approved or disapproved manually by a human. So what I decided to do is I said, okay, let me take this data and see if I can use AutoML tables to predict if an application is going to be approved or declined. And can this then eventually be used in a productionized use case? It can, so we can expedite the process of application approval. So now we get this new batch of applications, in this case 78,000. How fast can I approve or decline the applications? And I'll demonstrate that for you as well. So for the demo, let me jump into the demo. All right, cool. So what you're seeing right now is Google Cloud Platform Console. If you go to the menu, you'll see all the different services. I've already drilled down into the Google AutoML tables. I have my data sets, and I've already kind of pre-trained one. So I'm going to click on this one data set. What I want to highlight is these tabs on the top. This is the process that you go through the journey when you're doing AutoML tables. So you start here, and then you basically end here. So you have to start with your import, and I'll demonstrate that. But I'm not going to import a data set, but I'll just demonstrate the process that I've done before. This process can take some time depending on how large the data set is. So this can take anywhere from a half an hour to a few hours. You can upload it from what we call BigQuery, which is core to this demo, which I'll demonstrate. You can also upload a CSV file, or you can even upload it from your computer. Once you have the file uploaded, you'll go through the import process, and what's going to happen is going to take you to the train tab. And in the train tab is where a lot of the settings and the tuning that you can do before you start to actually run the training on the model, on the data that you provided, which has to be, of course, supervised. This is a supervised learning process, so meaning that the data has to be labeled. What we're telling you from a summary perspective, we're actually telling you what's text, what's categorical, what's timestamp, numeric. This is something that most of us would probably do in Python to describe our data, to understand what that data set that we're working with. Here, we've done that for you, so again, no coding required. The next one is, what is my prediction? What column am I predicting on? In my case, since this is supervised, I have a column that's already has, if it's been approved or disapproved. So that is going to be my column that I'm going to use to have the model train on. And then we have the train model button. But before we get into the train model, we actually have something down here which kind of looks a little bit busy, but this is great relevant information. And things that you might think, okay, that's not a big deal. It highlighted a selector. But having null data in a model sometimes might not be good, and you have to account for it. And a lot of times the model might break if you send null data. So what we're doing for you is we're auto-detecting if data is null, and we're doing the selector for you. So again, nothing that you've done programmatically. This is all done through a graphical interface. The other thing that you've noticed here is categorical. So in a categorical might be, let's just say, a grade K through 12. And we might actually have grade K, 1, 2, 3, 4, etc. We can't send that to a model. We have to encode it. So we have to turn it into a categorical value. The AutoML tables is done that for you. So again, this would have to be something that we would have to programmatically say in code, say, hey, take this column and all these rows associated that are grades and convert them into a 0, a 1, a 2, or 3, or 4, etc. Well, AutoML tables is doing that for you. And we've auto-detected that it needs to be a categorical value. The other thing that you'll see here is the text. So we do handle text. And text becomes very problematic in training machine learning models because it can be a lot, and we have to do things like encoding and sparse matrix. Again, that becomes a big burden when you're going through that journey of building that model on your own. We're doing that for you with this process, so we're doing all the creating those matrix for you of that text. And the other one that I'd like to look at is also the correlation with the target, is how important is this column to my target value? And the values are basically from 0 to 1, and the higher if it's closer to 1, it's more relevant. 0, less relevant. You can add some additional parameters, split the data. I'm not going to get into that, but you can train the model. Now, training the model does take time, depending on how big your data set is. So this can take anywhere from an hour to 24 hours to 2 days. Again, if you're talking 200,000 records, not that big of a deal. It'll probably process it fairly quickly. But if you're talking millions of rows of data and an enormous amount of columns, so very wide, it might take some time. But again, you haven't seen me do any coding. Once that's done, it's going to populate the models, and you can actually have multiple versions of a model. And this is an important piece here, is that you actually get to evaluate the model. I'm not going to go through all this to here because there's a lot to cover in here, but things that you might want to look at is simple things like accuracy. How accurate is this model? What's my confusion matrix? How important are the features to my model? So all this would have to, again, been done through Jupyter Notebooks. You're now looking at it through a graphical interface that you've, again, not coded once, and you can say, okay, this model is actually not bad. It's 85%. Maybe my confusion matrix looks good. My F1 scores look okay. This all looks pretty good. I think this is a model that I want to use in production. So we go to the test and use case. So in the test and use, I have my batch prediction, meaning in my demonstration or the context that I said I have 78,000 records that I want to batch predict on. That's probably what I would do. I would do a batch prediction. I'd have 78,000 rows sitting in a database, and I say, okay, run this model against this data. I could do online prediction, meaning as applications are coming through, I can automatically approve and decline them. And then this is just basically some tutorials, some documentation. So if we look at batch prediction, we have at the bottom, I already did one. So I took 78,000 records and I predicted if they were going to get approved or declined, and it took about 9 minutes to process 78,000 records. So what I did is I just populated where my data is. Again, it could have been from a CSV file, or it could have been sent in a database, in our case, BigQuery. Once you do that, you'll have the send batch prediction. You click on it, and then you just wait, and then you basically get the results back, and it tells you, that it processed in 9 minutes, and then you can go access the raw data, which instead of me accessing the raw data, what I did is I just built a quick little visualization. So I mentioned before that BigQuery is core to this kind of demo. BigQuery has a very open ecosystem, meaning we allow visualization tools like, Tableau, Looker, and others to access BigQuery. So now I can visualize my data, and we're actually looking at Data Studio, which is a Google product, but I can visualize my predicted data that I just ran through a batch prediction. So here you can see I can check what are the highest decline categories, what are the highest approved categories, what are the states that are most declined, and just some just generic statistics, right? How many records, how many were approved, how many were declined, what are the grades? So again, that journey, you didn't see me. There's no program required, no programming required, no hot encoding, no feature engineering. All I'm doing is telling where my data is. I'm taking it through that journey through AutoML tables. I have a model that I can use now. I send a batch prediction to it. I now have predicted data that I can act on it. And in this case, I just built a visualization tool for it. So that is it for the demo. I think, yep, that's it. So thank you so much. And definitely reach out to me if you have any questions.
Great. Thanks so much, Rui, for the demo. And next up will be Michael Tjalve from Microsoft. Michael will demo Cognitive Services Bot Framework. And similarly to Rui, he'll do a quick introduction to conversational AI and application to humanitarian challenges, and then provide a demo.
Yep.
Michael, over to you.
Can you see my slide, my screen?
Yes, thank you.
Perfect. Okay, so yeah, I work on conversational AI at Microsoft, and I'm here to talk to you about some of the tools and services you have available today for integrating AI into solutions, some of the challenges that you're working on. And so I'll give a specific example of a project where we've done just that, and I'll show how you can easily and quickly build a chatbot and deploy it. So first, just for context, what is conversational AI? It is a set of natural language technologies that simulate capabilities we typically associate with human intelligence. So this includes primarily speaking, hearing, and understanding. And this can be based on text interactions or spoken interactions. And it sort of enables the natural language as an interface to technology, to the digital world, to online content. And the reason we're having this discussion today, as opposed to, say, 5 years ago, is that AI has matured significantly in the past few years. And this then opens up for interactions with technology that were impossible just a few years ago. So chatbots provide a really powerful and sort of engaging interface for interacting with your key audience using conversations as an interface, which makes for a really interactive experience that is more engaging through persona building and an intuitive multimodal interface. It facilitates access to technology, which means that it facilitates access to services and tools by improving cost and scale and reach. And so it enables experiences that are available anytime, anywhere. And so here's an example where we're taking a problem statement from a humanitarian sector and leveraging AI. And we're working with one of the NetHope members to develop an experience for conflict-affected youth who are out of school with limited access to quality education. So it's a chatbot experience built as a virtual learning companion and a mentor that guides the user through a learning journey and helps with discovery and access to learning material that's relevant to their individual context. And so the key point is here that there are AI tools and services available for you to use today. I'll show you how to quickly create and deploy a chatbot building on top of bot framework and cognitive services and using our no-code authoring experience in the Power Virtual Agent. And I'll use the learning companion use case we just saw. But you can easily, of course, adapt it and apply this to your own area. So I will give a brief demo. So this is the Power Virtual Agent. And this is sort of the landing page when you first open up, starting with a new bot. So you can author your specific topics and then you can publish it, and over time you can sort of track activity usage over time. But for now, we're just going to start building out a very basic bot. So this is what comes out of the out-of-the-box experience. It comes with a few existing topics or intents, which define the conversation between the bot and the user. And we're going to add a new one here. Let's call it course. And in order to start the conversation between the bot and the user needs to say something. And so let's say user wants to say, I want to take a course. I'm interested in learning something. And you can add a few more here to add some variety around what you want the user to be able to say to get into this specific topic. And then we go into the authoring canvas, where we can add a little more detail into this. And so we can start by saying, so as you can see, this is the dialogue tree where you define the conversation. And so you start by saying, as a reply from the bot to the user. That's great to hear. And then we'll ask a question here. So we can say, which areas are you interested in? And since we're just getting very started with a very basic bot here, we can create in just a few minutes. So let's add support for two options, languages or business. And you can see as I type this in here, we create the continuation of the conversation tree here. And so if the user picks languages, we'll have a message that says, or we will ask a follow-up question to find out which specific languages you're interested in. Okay, I have courses for these languages. And let's say we have, just add a few here, English, French, and Spanish. Oh, yep. And once you've gotten down to each of these, we can then, so you can continue the conversation here. For now, we're just going to add a link to a course here. So I have this English course for you. And I'm going to just paste in a course link. And so for this specific project, we are, with the refugees, we're working with course providers to make sure that the courses are available for free to the users. Let's add this with French. I have this French course for you. And Spanish, I guess you can imagine what I'm going to put here. Spanish course. All right, so this now, let's zoom out a little bit so you can see the tree better. So this now follows the conversation from having gotten into this specific course selection topic, selecting one of two options, and drilling down to the specific language and then getting a course point provided for you. Let's just add one for business as well. I have this course on entrepreneurship. All right, and that is it. That is really all it takes. So I'll save this, and then as this is saving, I'll open up. You have this test experience, so you can see, you can try out the experience before you deploy it to your users. And I'm going to turn tracing on, which shows, as I'm moving along in the conversation here, it shows me on the right side where in the dialog tree I am. So let's see, user says, I want to take a course. And you can see it finds the node here on the right, so you can follow the conversation in case you want to change something as you notice, in case that there's an unexpected behavior or an unexpected wording, you want to fix something, you can do that right there. And you can either click the buttons here, these become buttons, or you can do freeform typing, and then you can type. That brings you to then a course outside. And in order to publish, so this is a full bot created in just a few minutes. Of course, this is very, very basic functionality. You can add a lot more sophistication and complexity to this, but this is just to sort of show you don't need to think about AI really. There's a lot of AI running underneath here, but you don't need to add anything. You don't need to train any models. All you need is content, and you need to know your users. And you can publish this bot with just a few clicks, and then that becomes available. And you can create a demo website that you can share with your friends, colleagues, if you want to get some feedback before. This is then a demo set, but you can just share that URL if you want to get some feedback from users before you go fully public with it. To take our course. And that's it. This is a live bot that is available to anyone you share this link to. And if you publish it, for example, embed it into your website, you can embed it into, say, NetHope.org website or any other website. And then gradually you can build the content out of that. And so that is it for the demo. So I hope you can see how easily it is to leverage the power of AI and building a very easy experience without needing to know anything about AI or coding. And you can start to think about how you may be able to connect this to your challenge space and sort of engage more deeply with your audience. So I'm happy to address any questions you may have either in chat here or by email afterwards. Thank you.
Great. Thank you so much, Michael. Thank you for also demystifying the creation of a bot. And hopefully this gives a good overview of how you can get started without having technical expertise, specifically AI and ML expertise. And one of the things that you highlighted is that really the need to know the target audience, also specific to the bot, for example, to have a library of content and that would be relevant to that target audience, and to build a persona that's engaging for that target audience. So each of these tools and services not only can be used relatively easily, but also require just a different approach and thinking through how best to incorporate them in our international development programs. So the next up, we have two demos of computer vision solutions. The first one is from Salesforceorg, and Alex Kruglyak will give us a demo of Einstein Vision and Einstein Playground with a brief introduction first to the work that Salesforceorg is doing in AI space. Over to you, Alex.
Thank you, Leila. Can you please confirm that you can see my slide now?
Yes.
Thank you. Greetings. So yeah, I'm Alex Kruglyak, and I'm a principal solution engineer with Salesforce.org, and I'm thrilled to present Einstein Vision. So how do we think about AI just in general, not just in regards to vision? So there are four major stages of AI process. It starts with capturing of structured or unstructured data. And structured data are the records in your database or in your CRM, and unstructured data could be text or images. In our demo, we will be using photos specifically of chimneys. After you have your data, it's time to create a model based on your data. Your model can be using either machine learning, natural language processing, NLP, deep learning, or some other algorithm. Basically, your model learns from your data in order to be able to predict outcome. And when you give a new piece of data, it can predict an outcome from that. And with Einstein, we provide that prediction within the context of your everyday workflow. That's typically within your CRM, or you can embed it into another application. And finally, we want to capture feedback from predictions in order to refine and retrain that model with even better data. Now, while my demo is focused on Einstein Vision, Einstein family of products actually encompass a spectrum of different capabilities. And it starts with out-of-the-box AI for business users within areas such as nonprofit, sales, service, marketing, or commerce. And the next set of capabilities fall under point-and-click AI for admins. This includes voice assistant, bots, Einstein Discovery, and Prediction Builder. And finally, AI services with tools such as Einstein Vision, Einstein Language, and prediction services. Now, before I jump into the demo, let me just describe the use case here. So this demo is based on real customer use case. And the customer is Proyecto Mirador. It's a nonprofit that builds clean cook stoves in rural Honduras. And their work empowers women. They create jobs, reduce carbon dioxide emissions that contribute to global warming. And with their good work, they're offsetting 1.4 million tons of carbon, saving 7 million trees, and changing the lives of 800,000 people. And Proyecto Mirador was looking for an efficient way to do quality control and to manage 3,000 to 5,000 stove installations per month. So that's quite a substantial number. And with the help of Salesforce partner Mowgli, they implemented Einstein Vision and Salesforce Nonprofit Cloud. So now they simply take a picture of the chimney with their mobile phone, and via Mowgli SMS text message, they get feedback whether the installation is good or not. And you can see a picture there of someone doing that, exactly that. And so in the demo, you're going to see how we can use Playground to train image classification model, all through point and click. And so you don't need to be a data scientist in order to do this. And so with that, let me actually jump into the demo. All right. So I'm excited to walk you through Einstein Playground, a free tool that you can find on Salesforce App Exchange. And we're going to focus on in our demo on Einstein Vision capabilities, but note that Playground can also be used for language sentiment analysis as well as intent. Now, Playground is a point-and-click tool that allows you to upload your data sets. In our case, we're using images. And with that, we create a training model and manage Einstein platform account. Now, you can see in the intro tab here, we have how-to instructions to guide you through the process. And there are additional resources available, such as documentation and hands-on training on Trailhead. Now, in our use case, we're trying to determine if chimney is good or bad. Remember that slide that I showed earlier that illustrated 4 stages of AI. So the first one is capture, right? And in our case, we need to capture those images to determine whether a chimney is good or bad. And believe it or not, image capturing is probably the most time-consuming step of the whole process. Now, fortunately for us, the customer actually had shared close to 700 images with me so that I can build these data models. So you can see, I've got good images, I've got bad images. So that's what I used in order to build our model. And you can see in my playground, I've actually set up two models. One is around cats and the other one is around chimneys. Now, and when we look at cats, the data model, notice that we have various identifications or labels or categories, if you wish. So we're looking at Bengal type of cats, Sphinx, British short hair, and you can see how many images we used to train the model. Now, something to be aware of, you probably want to have at least 15 images for each category, but obviously the more images you have, the better. And in fact, if we look at the chimney data model, you can see that I used close to 700 images for both bad and good chimneys. So how did I create these models? So the first step is creating of a data set. So we're going to look at the data set creation tab here. And know that I can either load it from a URL or I can upload a file. Now, what I did before is I uploaded a zip file with all these images. I'm not going to do that again. So that was the beginning of my data set. So once we have our data set, the next step is to train the model. Now that I trained my chimney model, once again, I was doing some testing, so you can see a number of them, but all it takes is just to go ahead and start the training. So now my training has kicked off. Now, this may take anywhere from a few minutes, depending on how many images you've uploaded, to perhaps an hour. In the interest of time, we're going to move on to the next step. So with model in place, now I can test my images and see what predictions the system will make based on the training model that I created. So to start with, we're going to pick a model. Now note that out of the box, you already have some pre-built model. You have general image classifier, you have food image classifier, and you have scene image classifier. Now, in our case, we're going to use a specific model. And in this case, it's a chimney model. And I'm going to upload an image in order to test. And let me move this out of the way so I can get to my images. All right, let's pick an example of a good chimney. So now we have a picture of a chimney right here. Now, admittedly, cats would have been more fun to look at, but chimneys is what our nonprofit is using. And so in the background, what happens is that my image is being evaluated against the model that I trained. And so what it does, and it takes the image that I uploaded, in this case, this image here, and it now calculates in the background things such as what are good images, or what percentage is a good image, and what percentage is a bad image. It will also produce the raw output, and that's in the JSON format, just in case you want to use that somewhere else. But as far as kind of looking at this image in particular, you can see that 80% identified it as a good chimney, and potentially 20% a bad chimney. And we can do the same with, look at the bad chimney, but in interest of time, I'm going to move on. And also point out that, as you can see, it's easy to build and train a model, do a prediction, but also if you're a data scientist, you might want to look at some metrics behind all of this, right? So for that, there are screens like this. Now, if you're not a data scientist, this probably doesn't mean a lot. In the interest of time, I'm just going to move on, but you can see various kind of metrics that might be important to a data scientist. But in conclusion, that finishes the part of my demo, but I just wanted to point out that I've also put together some slides around resources that you can use to, if you're interested in vision, you can use these resources to start your journey with vision and AI. And with that, thank you. And if anybody wants to follow up after or in the chat, I'm happy to address your questions.
Great. Thanks so much, Alex, for this brief and informative introduction to how computer vision could be used in the nonprofit context. We will provide all of the slides, so you don't have to take the screenshots of what Alex is sharing. And do note that Alex, as well as other demoers, have provided input to that resource repository of tools, services, and trainings that we'll also share in the recap email. Just briefly, so you note, there was a question asked about Rui's demo, and I've asked Rui to respond directly in the chat window and share the link. It was Ketan Wabi's question about regularization techniques. We'll get to the couple of questions at the end of the demo, so do continue posting your questions in the chat window. And our final demo is actually a very interesting demo of machine learning at the edge in this connected environment with AWS Snowball Edge. And Grace Kitzmiller will provide that demo and obviously first brief introduction to AWS work as it relates to humanitarian sector. Grace, over to you. So Grace, we can see your slides, and let's test your audio.
Great, thank you so much, Leila. I apologize for that. Can everyone hear me now?
Yes.
Okay, perfect. So thank you so much. I'm really excited to be here today to share with you some details on the AWS Disaster Response Program and how you can use machine learning across the disaster lifecycle and especially at the edge. So just a real brief introduction to the AWS Disaster Response Program. It was launched in 2018 to really help nonprofit, NGO, government, humanitarian, and other organizations that are active in disasters to solve some of the biggest technology and infrastructure challenges that they encounter after a disaster. We directly support rebuilding connectivity and leveraging the cloud at the edge when infrastructure has been damaged. And this really involves us working with organizations prior to a disaster to identify key data sets that are important to have access to or create after a disaster occurs. And then also to determine the critical apps, including machine learning apps that either run on top of those data sets or to which having access can really make a difference in the response and recovery activities. We also work with different organizations to explore how machine learning can be used to inform situational awareness and to develop deployment procedures if appropriate. The program really revolves around three core components: people, information, and technology. So I'm going to walk through a few ways in which we use those components during emergencies. First, just a very brief note about people. The DR program has a roster of deployable volunteers who are trained and certified through organizations like NetHope internationally. We deploy those experts to really help augment existing response efforts. They provide support on the ground for up to 2 weeks to either provide technology continuity to local communities or responders, to help triage and assess technical needs, completing activities like installing and maintaining Wi-Fi networks and shelters. Our remote volunteers do things like call center overflow staffing and also have participated in a number of mapping activities. And we've supported responses after things like Hurricane Florence, Michael, the California wildfires, and most recently after Hurricane Dorian in the Bahamas, and that ties into some of the machine learning example we'll get into later. And just this picture here at the bottom starts to dive into the technology a little bit. These two gentlemen are holding what's called an AWS Snowball storage optimized device. And when Mount Kilauea erupted in Hawaii and as the lava flow spread, USGS was concerned that that flow might destroy the building that housed 40 years worth of imagery data. So we overnighted one of these devices, which I'll talk about more in just a minute, that can store to between 50 and 100 terabytes of information, and the team was able to actually download all of that imagery data and have a backup that's now accessible offsite as well. Onto machine learning on AWS. We have, AWS has a large number of customers using different services for machine learning. And as an organization, we've been making huge investments in this space for over 20 years. Many of the capabilities that customers experience with Amazon and AWS are driven by machine learning, things like recommendation engines, tasks that optimize robotic choosing routes and fulfillment centers, supply chain forecasting, capacity planning. Those are all fueled by and informed by machine learning algorithms. Alexa, if anyone has an Alexa, uses natural language understanding and automated speech recognition and deep learning. And also computer vision is being used through resources like Prime Air, the Amazon Go store, and through many other use cases. We also have thousands of engineers at Amazon that are committed to ML and deep learning. The AWS machine learning and artificial intelligence stack really has 3 different layers, and layers provide a great amount of flexibility to the different types of users of machine learning resources. First, we have the ML frameworks and infrastructure layer. And this is ideal for expert machine learning practitioners who operate at the framework level and are comfortable building, training, tuning, and deploying their own machine learning models. At the ML services layer, this is really ideal for everyday developers and data scientists. These kinds of users can take advantage of Amazon SageMaker, which is an Amazon managed machine learning service that can be used to build, train, and deploy machine learning models quickly. And at the top layer, we have AI services, which can be easily used by developers or organizations looking to start using ML, but also have no prior experience. These services can be used to build sophisticated AI-driven applications like a contact center, chatbots, media subtitling, understanding voice of the customer, and many more kinds of activities. What I want to talk about next, continuing in the technology discussion, is the AWS Snowball Edge device. And this really starts to dive into how can you bring cloud capability to the edge in a disconnected environment and have an impact on your disaster response activities. As we focus on really helping different organizations solve their biggest technology and infrastructure challenges in those low and no connectivity environments, like a Snowball Edge can come in very handy. This is a picture of the Edge device. It's a ruggedized device that you can use again in a connected or disconnected environment. It's really a little bit of a cloud in a box. It runs Amazon Compute or EC2 instances and comes with AWS S3, which is a simple storage service on board, and also runs Lambda. There are several different flavors of this device. Some are just optimized for storage, as we saw with the example in Hawaii, and some are optimized for compute and processing and things like machine learning at the edge. And some of the compute optimized devices also have a GPU on board and can provide even more compute power. The device is tamper resistant, and everything that is stored on it is encrypted with 256-bit AES encryption. And this weighs about 22 kilograms or 50 pounds, and generally is shipped via, here in the United States via UPS, and can actually be baggage checked on an airplane. This is just a quick summary of the services that are available. From the S3 perspective, or the storage perspective, you can store anywhere from 50 to 80 terabytes of information on the device. From a compute perspective, you have 52 virtual CPUs available for processing. And here are a couple real world pictures of the device, just to give you some sense of scale. So on the front, you see we've got our airline shipping label on here. This is where you have access to some of the networking and connectivity information. This second image is from a field use. You can see it's just kind of laying here on the dirt floor, with the front view is actually in this one. And this last slide is, I'm sorry, this last image is a picture of the back of the device, and it shows you where the power supply is plugged in and the different kinds of access points and different connectors that are available. So just moving into the demo, and this will be, the demo itself will be very short, but what I'd like to do is just spend another 30 seconds talking about what the demo actually does. So we've seen how you can, you know, really across different cloud services, you have the ability to train your deep learning models. One thing that you can do with the Snowball Edge is after you've gone ahead and, you know, trained and developed your model, you can now provision it to run on your Snowball Edge device. You can also provision any information to bring with you to the disaster site onto the Snowball Edge device. And some of the things that we've seen already are organizations that would like to bring, you know, a bit of pre-disaster geospatial imagery with them, and maybe fly drone operations out in the field, and then use the Snowball device to actually process that drone imagery in the field and push out those results in a much more compact form so they can communicate those much more quickly. So for this demo example, in general, we would have, using the AWS console, provisioned a Snowball Edge device with the operating system, the models, into what we call an Amazon machine image. Once the device is visioned and it's delivered, you can now hook it up to, you know, for this computer vision example and detection, something that can stream video. It could be a phone, it could be a drone, it could be something else. The Snowball device itself actually hosts the object detection model running on it, as well as the output page, where any objects that are detected are actually, you know, shown on that page that is hosted. Now, if you're in a disconnected environment, you can connect a Wi-Fi router as an access point into this loop, and then you can actually hit that output page directly across that Wi-Fi router. So let me switch over to the demo page here. And my apologies, we seem to have lost our connection. I seem to have lost the connection to the demo itself. Okay. Well, as a backup, just in case we did lose connectivity, I took a screenshot of the running demo. I'm not exactly sure what happened, but I know we're short on time. So we won't actually be able to run this from here. But this is basically a screenshot of the video that we collected during a recent disaster response event. And this video is actually streaming through a Snowball device. And as it was streaming through, you can see it's detecting things like people that are in the field of view. And so this is really just a brief example of how you could use computer vision at the edge to really start to, you know, think differently about, you know, what could be possible if you can bring that data with you, bring those apps with you, and if you're able to run either in a connected or disconnected environment, and then send that data back up to your offsite response organizations, how that can impact your priority setting and your situational awareness. So appreciate your time today, and thank you so much.
Great, thank you so much, Grace. So we're gonna switch to the slide where we have everybody's contact information as we're running short on time. Hopefully this brief introduction to several of the off-the-shelf AI and ML tools and services was helpful to many of you. We do recognize there are many more that we could demo, and do let us know if you'd like to see any additional demos or even contribute and share the work that you're doing. We've answered a couple of questions already in the chat window, just in the interest of time. We do have time just for one final question that we got from Meredith, and the specific question is for Alex at Salesforce.org. For Salesforce AI, Meredith believes that you stated that 700 images were used to train the model. If it were sales calls, a mix of text and structured data, would 700 rows be enough to start? Was there a place to view model accuracy in the playground? If you could just briefly say a bit about that.
Yeah, great question, Meredith. So yeah, depending on the type of data that you're analyzing, whether it's image, so unstructured data, text, which is unstructured, or structured data, which might be your calls, there are certain guidance that we provide as far as number of records. In some instances, it could be 1,000 records. The more records that you have is obviously better for the accuracy of the model. And what I can do, I can follow up and provide some additional links where we give you the numbers and the guidance around the different types of data.
Great, thank you, Alex. And similarly, if you have any additional questions for Rui, Grace, Alex, or Michael, do feel free to follow up if you want to see any additional demos. This is just a quick introduction to demystify some of the work that we see around and conversations that we see around AI and ML, and also to help you kind of get started with experimenting and exploring these tools and services for your work. Huge thanks to Grace, Alex, Michael, and Rui for the demos today. And also, I do want to mention that they spent about 5 days with us at NetHope Summit with 500 representatives of 50 plus global NGOs and our partners, and contributed greatly to a number of AI sessions that we had at the summit. So thank you for also bringing one of the sessions to the broader NetHope community. Thanks again. And our next webinar in the Emerging Technologies webinar series is this Thursday, and we'll be focusing specifically on digital identity and technical requirements that enable interoperability and procurement. So hopefully we'll see some of you this Thursday too. Over to you, Madeline.
Thank you, Layla, and thank you to all the attendees for spending your hour with us today. Please take a moment to complete our webinar satisfaction poll before you sign out, and have a great rest of your day.
Thank you.
Thank you.
Thanks, everyone.